All right, here we go. Hi guys, it's me again. And I'm now going to prove number 4. Oh, I should probably write my name, right, so that you know who I am. This is me. Can you see that? I think you can see that. Awesome. It's still me. This is still Judy Mizraki. Okay. And this is still for this class. Okay. And this is homework 1, problem 4, where it says prove or disprove. I'll show you. It says prove or disprove. You see that? 4. Prove or disprove that if PA equals PB equals PAB, then A equals B, probability 1. Okay, fine. Well, by definition in the book, let me actually get the book so I can actually read this, because I know this before I read the book. Sorry about that. It says that by definition, A and B are considered equal with probability 1 if and only if this, right, which is the same thing as this, okay, if this set has probability 0, has 0 probability, okay? Now, this is kind of a really fancy way of saying something that I think is actually not quite that complicated. I think that we could really prove this just by basically proving that this probability of A not B, okay, and the probability plus the probability of B not A equals 0. Yeah, that should work, okay? So if this is true, okay, this implies that A and B are equal with probability 1. That's the same thing as this. These are the same things, okay? This implies this, all right? Awesome. So now let's go back to the question. So our question is, if probability A equals probability of B equals the probability of AB, okay, then A equals B. Does this imply, I want to know, does it imply that A equals B with probability 1, which is the same thing, okay, as this? All right, so really we're just going to prove that this implies this. And we just show that it's a one-way streak, and then we're good to go, okay? So let's see if it's true. Well, let's consider, we're going to start off by assuming this. So let's say suppose the probability of A equals the probability of B equals the probability of AB, okay? Well, we know, of course, that, oh, this is cool. We could do this. The probability of A, right? Isn't that the same thing as the probability of AB, okay, plus the probability of A not B? And the reason why is because the probability of AB, okay, is just this part, okay, and the probability of A without B is just this part. So notice, see, this is A and this is B. We get the whole A. See how that works? And of course, the same thing's true with B. That this is the same thing as the probability of AB plus the probability of without A and B. Okay, so this being said, we can do some kind of cool stuff with this, right? Because that means that the probability of A not B is the same thing, we're going to use this over here, okay, as the probability of A minus the probability of AB. But notice, if this assumption is true, okay, then probability of AB is the same thing as probability of A, so this equals 0. All right, cool. And similarly, the probability of not A and B equals, can you still see this? Yeah. Probability of B, so now we're using this one, minus the probability of AB, sorry, which is again equal to 0 for the same reason, right? Okay, you just stop for a second, make sure that all makes sense. Okay, cool. So what are we going to do next with this? Well, now we have our work cut out for us, don't we? Because we're just trying to show that this equals 0. So this implies that the probability of, therefore, we'll do this, okay? The probability of A not B plus A not B, which is the same thing as the probability of A without B plus the probability of AB, not AB, okay, is going to equal 0. So therefore, A equals B with probability of 1 by definition. Boom! Awesome. Take care.